The model reported here shows how the microcontroller can be used to measure voltage, current and temperature of power systems. Though this presentation only gives you the minor details, students interested in doing a project on power system can get the rough idea about the various components used in this project. A separate setup is used for monitoring the voltage, current and temperature, and for all these things the processing unit is the microcontroller. The internal ADC of the microcontroller is provided with a 2.5 volt reference, and based upon this reference voltage the analog signals corresponding to voltage or current or temperature and all these things are read by the microcontroller. Power system monitoring and control means the or refers to the basic technologies used in monitoring, protection and control of power system over a wide area. A varieties of problems can be discussed or can be solved by researchers in power system monitoring. This includes the problems encountered when addition of renewable energy sources and how the protection should be done in smart grids, and you can also go for wide area stability, coordinated voltage regulation and angle oscillation damping, as well as the advantage of employing phasor measurement units and the GPS systems. So in all these areas students planning to work on power system monitoring they can do research, and you need to have a broad area or a broad knowledge about the various advancements in metering and control techniques and practical feasibility of the solution whichever you arrive out of the research. What is the practical feasibility of this solution? These things also you should be aware, and you should have the understanding about the recent topics in protection such as smart grid or microgrid, and what is the meaning of coordinator voltage regulation and how to achieve angle damping. These things and all the researcher should have a basic knowledge, and then only you can work on power system protection and monitoring. The electrical parameters like voltage, current will be continuously compared with that of the standard reference voltage, and in case of any overload or short circuit fault or voltage surges, these conditions can be immediately reported to the main substation. For this we can employ this RF based monitoring system. Suppose you want to have a still long range of control, suppose you want to have a long distance communication, in that case you can go for GSM based control, wherein an SMS alert can also be generated. The use of GSM makes the entire system intelligent for the reason that it transmits alerts and informations, as well as it can also receive commands. This enables to reduce labor cost at the substation, and the monitoring and protection efficiency is also improved. The entire design is based upon the microcontroller 16F877, and the RMS value of the secondary voltage for the transformer which is located in the distribution side, and that is to be monitored. and further, if necessary, you may extend this module for monitoring the power factor and reactive power, active power. These things also you can extend the same project. The prototype is done by using a single phase transformer, and auto transformer is connected to the experimental setup to create various input voltage scenarios. And in the voltage measurement module, you are using a potential transformer, that is 300 bar 5 volt, and this 5 volt, it is AC, that is converted to DC, and it is reduced, the voltage level is reduced, and a zener is connected, 4.7 volt zener is connected across the sensing terminals. This ensures that the voltage level of the microcontroller is not exceeded. The sample rate of this microcontroller, that is set by the program. The same working principle we have for the current measurement module also. The only thing is that instead of the voltage sensor, here you have the current sensor. And the current transformer, you need to have a resistor, current sensor or the current transformer, that is always short circuited. For this model, we have used a 0.6 ohm 30 watts shorting resistor. It is called a burden resistor, and different loads, we have arranged a bulb load, that is called load banks. Each bulb of 100 watts is connected, and different load scenarios are created by using switches. Different loading conditions are generated, and with the various values of current readings, that is displayed in the LCD module connected to the microcontroller. Similarly, for frequency measurement, you can do that by using the sensing part, that is achieved by using the comparator. You can use a comparator based on LM741 that will find whenever there is a zero crossing. So zero crossing from negative half cycle to positive half cycle, and zero crossing from positive half cycle to negative half cycle. So this you need to detect. So once the zero crossing is detected, that zero crossing pulse, that you can use it for the microcontroller. So based upon the zero crossing pulse, that is the distance between the two zero crossings, that time value is used to calculate the frequency. So this way the frequency module works. Separate board are used for the voltage measurement and current measurement, and anyway, the microcontroller can be a single unit. The sensor part is assembled on separate boards, and final output from the microcontroller, you can even read it to a PC. In that case, you can use serial communication. Again, in serial communication, you have synchronous and asynchronous mode of serial communication. Asynchronous mode of serial communication involves the Welcome to Expert Agencies, Center for Research in Power System and Power Electronics. We provide MATLAB coding as well as hardware development for researchers. Our areas of expertise includes embedded system, VLSI design, ANN, fuzzy, power systems, power electronics, machines, control system, biomedical engineering, and wireless communications.
For researchers, we provide them with reference papers, presentation material, notes materials, project hardware, training classes, and for PhD scholars, we provide assistantship for getting their papers published in national and international journals. For students willing to do the project at our institute, we provide them help to assemble their hardwares, and we do provide training in MATLAB so that the knowledge obtained through the MATLAB training that can be effectively used in development of their project codings. For power system students, we provide guidance in deregulated power system, wind energy generation, unit commitment, economic dispatch, voltage stability, transformer fault identification, SCADA, and distributed computing. Students interested in taking projects in these areas can contact us through mail at our email ID expert